Good evening, everyone. Welcome to day 4 of the Quality Week session organized by the Colombo Quality Camp community. We are excited to have you join us online. My name is Dee Saharni, and I will be your moderator for the evening. Before we get started, a small reminder that if you have a question for the speaker, please type it in the chat, and I will help convey the question to the presenter. Let's get started. It's a great pleasure for me to introduce our speaker for the day. He is the head of software quality engineering in Zone 24/7 with experience in test management, test automation, performance engineering, and application security, working for Silicon Valley-based IT firms with over 11 years of experience in software quality engineering. Without further ado, we will turn the time over to Chandima Athapattu, head of software quality engineering in Zone 24/7, where he will dive into the non-functional testing Quality 2.0 in this session. Over to you, Chandima.
Thank you, Dini. I hope you can hear me well and you can see me.
Yes, Chandima, we can, yeah.
Right, okay. All right, good evening, you all. So I'm glad to be here today and speak to you, ladies and gentlemen. First, I would like to thank Colombo Quality Week committee, the organizing committee, to give me this opportunity, right, and talking to you today. Okay, so let me first share my screen. All right. Could you please confirm, Dula, Dini, you can see?
Yes, we can see the screen, yeah.
Oh, okay, well. Right. Okay. So, Dini, thanks for the introduction, Dini. So, she mentioned the topic, right, the non-functional testing, quality 2.0. So, here we are going to talk about non-functional testing, and I'm going to sit a fairly high level because I think all of you know this is a very broad area, right? So, we are going to discuss a fairly high level some very important facts about non-functional testing. I am pretty sure that when you are done with this quick session, you will take away key points that you need to plan non-functional testing in your projects. Okay. Right. So I'm going to skip this slide as Dini's excellent introduction. Thanks a lot. And I think I'm Chandima, and I'm really passionate about quality. And I'm really passionate about improving quality within the industry and speaking like this to the betterment of the industry. Okay, so let me, right. So why non-functional testing? So why I choose this area? So this is a key consideration, right? So I think that is something when we compare to 10 years back, 15 years back to quality, and now it's totally different thing. The people who are entering into the quality industry 10 years back, the way they should think, and now it's totally different. Okay, this is based because of key areas. The first thing is, now we need to understand the software applications we build, our software development community build. They are getting more complicated because the technology is evolving and they are more complex. So there are more integrations. Those are the reasons these are getting more complicated. Okay. And with this, now more production issues comes with non-functional aspects compared to the functionality, because functionality is something already well written, and our QA teams, they are doing the testing with a spec, and they are well, most of the time they are well written and well tested. But when it comes to production issues, many production issues comes with non-functional aspects. So that is another key consideration that we need to pay our attention to non-functional testing. And when it comes to threat to the business operation, the day-to-day threat is higher compared to failures in the business functionality. Because when it comes to business functionality, maybe the client or the customer or the owner of the software can do some alterations or some adjustments, right? But when it comes to non-functional threats, it's very time-consuming to fix, and the threat is very high. So once exploited, the whole operation may get impacted. And the other main area, other key thing is, it's very hard to, when it comes to quality, it's harder to compare to the functional quality, okay? Because it's hard to test. That's something that we need to consider. So those are the very key consideration areas when it comes to non-functional testing. So moving on, what is quality 2.0? Certainly this is not a standard, okay? So software may survive in functional quality if operates in small target audience. It may be, because let's say we have a software that is maybe developed for very restricted access or maybe very small audience. It's small, maybe those will survive without non-functional quality. But when you are scaling and when your software becomes larger and your customer base is wider and broader, you definitely need to consider about non-functional aspects, especially if your solution is going first time to the production. Even after your first time go live, still you need to continue non-functional testing during your maintenance phases. So in this situation, functional quality is kind of 50%. Okay, other 50% is about non-functional aspect. So we will discuss more about what are these in high level, right? So quality 2.0 is nothing but, I just wanted to highlight, it's the next level of quality. Comes with this performance, security, and usability. We are the three key areas when it comes to non-functional aspects. Now, first of all, discussing more about these areas. So we need a solid understanding on few areas before that. So if you think that you would like to reach to non-functional testing aspects, you definitely needs to strengthen your abilities on these areas. So software requirement specification, something mandatory, even to non-functional testing. You might figure out, let's say, certain times you might not have non-functional requirement in certain projects, maybe based on your situation, but it's a must if you are going to do that. Okay, you need to have a written specification. These are the requirements from the client. These are the key areas from the client that we need to target when it comes to the non-functional aspects of the product or the solution. The live operation scenario, the production scenario, and the current status. Something that you need to identify and analyze, because let's say when we are starting testing for the first time, maybe we are receiving a QA release from the developers for the first time, and we are thinking about the functionality, and we are never worrying about how it will work on production and what will be the live operation, who are the customers and all. We might not think, we might think about the requirement and then we test it. But before you start on the non-functional aspect, you should realize what kind of production scenario is this. And then the infrastructure and the deployment. Because nowadays, the infrastructure and deployment is evolving rapidly. Okay. So as quality engineers, we need to stay up to date with the infrastructure and with the deployment to do robust non-functional testing. Otherwise, we are doing data testing, which is not up to date with the new technology. And the most important thing, number 4, the end users and how they use the system. So that is very important to understand. Who are the end users, from where they are going to test and all, from where they are going to operate. And finally, verify these above 4 steps are achieved before you start thinking about non-functional testing. So this is the basis. All right, so now 3 focus areas. Performance testing, usability, security. You might heard these things well before, right? But why we wanted to discuss a bit more and more about these areas? Still, because these things are up to date, I mean, very rapidly changing with the time, with the new demands, the technology, everything is there. So you need to stay up to date with that. So that's how you have to, you can do a very robust test, very sophisticated and robust, which is up to date with the new requirements. So today I'm going to focus on these 3 areas, and I'm going to explain top, I would not say top, but 10 tips about these testing. Right. First, I would like to discuss about the performance testing. I think after this session, you might heard about a very I think, scenario-based performance test from Sugandhika, right? So I think this will be a very much introduction to that even. Now I'm going to set some stage with the overview. So key areas you need to think about when it comes to performance. It's not only about how you test it. So you need to think about the infrastructure and deployment. That's the first thing. And then you need to think about the software artifacts. When I say software artifacts, it can be different documents. When it comes to design documents like software architecture document, maybe test plan, maybe SRS, the non-functional requirements, everything you should have it. Then you need to think about the parallel users. Does my software having parallel users in production, or do I need to consider or not? You need to think. Then from the other side, you need to think about the data volume. Should my system, a solution using huge data, bulk of data, maybe it can be a processing or storing or transmitting, you need to consider that. Then the longevity, you need to make sure that how far my solution will consistently operate by a single customer or set of customer. Is that a live, 24/7 so up and running functionality, or the whole flow will go for like 1 or 2 hours? What kind of behavior that my system having? So these things you need to realize when it comes to performance testing before you start doing something. So then these are the typical stages of a performance testing, right? Typical milestones. So planning, you start with the requirements, you identify KPIs, environment, you are preparing the environment. Then you are moving to the scripting. So that's where you are automating your APIs, and then you are making sure your data is in the correct place and making sure you are having parallel use execution as you need. And then you are making sure your scripts are like browser-like behavior is there. So everything is there when it comes to scripting. And then you go to execution. That's where like you have the trial runs, consistency, load stress, all these different types of performance testing is doing. And then finally, you are doing the monitoring in the server side and client side. And then the reporting, that's where you do all the results and observation issues and all the metrics and all that is coming to picture. Now, with all these typical classic, performance testing milestones, now what's the change that you need to think about? So you need to think about new technology now, right? For an example, if your solution having predictions, okay? So if your solutions having predictions like machine learning or data science models are there, you need to think about how those come into picture when it comes to performance testing, how they should be tested with performance. So did you ever thought about that? And when it comes to deployment, from classic on-prem to cloud deployment, you need to think how cloud deployment can add more complexity to the performance testing, to the typical performance testing. So if you do a performance test in a usual on-prem solution, and when it comes to cloud, it's totally different scenario. So then you need to think about different technologies, like let's say nowadays with other than APIs, the RESTful APIs, there are many more technology when it comes to communication, like transferring real-time data, like webhooks and message buses and like them. So they are like sitting like message queues, and we have these published subscriber models. So you need to see how that architectures will impact the performance testing. Should I always consider, even that's APIs, the behaviors are different. Okay, so you have to consider the impact of these technologies in your solution. And then the container deployments. Now it's very rapidly improving, using more and more containers to deployments. So how container deployments, container utilization may impact with the performance testing. How it will impact to monitoring the specs, monitoring the logs. So those things you have to consider. So those things which are, I think 10 years ago, we never thought of those areas. Right. Then I come to 10 tips. So first thing, if not already, understand the business use case, something very important. And then understand the uses and parallel usage, like I mentioned, and the data volume. those are different things. When it comes to users and data volume, two different things. Certain projects may have parallel users, but maybe not data volume. Certain projects, certain solutions may have data volume, but may not have a parallel usage. So you have to plan your test accordingly. So when defining test scenarios, focus on server-side and client-side performance. That is another tip, because you can't really focus on only server-side or client-side. You have to understand good gravity based on the situation. What level of focus should I pay attention like to server-side and to the client-side, right? And the number 5, the test environment. So now when planning test environment upfront, so you need to make sure the production environment is equal and the deployments are similar. So you should have a good understanding about the architecture of the solution and even the resources like CPU memory. You need to have a good understanding. And not only that, because in practically always it's not realistic, I mean, to have similar resources when it comes to your performance test environment, due to many reasons like cost and all. So you have to plan your test accordingly. Let's say you have a downgraded environment compared to production, but what you can do is you can do the performance test and say, based on this spec, this is how it will work. And you are going to forecast based on this, how it will impact to the real server. Okay. So like that, you have to plan your test. So the next tip, get ready with a server monitoring tool upfront, because most of the time we are forgetting about preparing a server monitoring tool, so that only, I mean, finally, in the very last moment only we are trying to figure this out. But having a monitoring tool set up with your DevOps and all takes some time. Okay, so it have maybe a cost. So you have to pay attention to that. And number 7, about logs. So when it comes to logs, something very important to troubleshoot performance issues and debug them and monitoring. So you need to make sure logs are accessible. And when it comes to container deployments, there are different set of logs and correlations are there. So those are typically developers put correlation IDs to locate a particular transaction from end to end. Because when, let's say, there is a particular transaction, you have to analyze multiple log files, so that how you locate the similar flow within a different file using a correlation. So you need to make sure those are in place. Otherwise, you can't troubleshoot correctly. So those are things like, it's not only testing is our responsibility. We have to make sure these things are in place before the test. Okay. Then the synthetic traffic. So whatever you generate with your tool, the synthetic traffic, you have to make sure it's realistic as possible. How you do that? You have to make sure you have to simulate the production behavior. Maybe you have to put correct delays within the APIs, or maybe you have to operate the correct time of the day. It will impact. And also, not only that, you have to think about the network, because what would be the production network latency and what would be the testing environment latency. So if the tools are not matching, your test is waste, because you might observe a huge response time, but real production may not observe it. So you have to pay attention to network latency also. Then the data. You should be able to identify data later using maybe some querying the DB, so that it'll be easy for you to backtrack and see what kind of impact the database is having with the performance tested data. So whenever you are generating some data to performance testing, you should be able to identify it later. In case your other testing, manual testing, automation, everything happening in the same environment, even the performance, then you have to make sure that performance data is something identifiable. And then finally, the report. This is not something that you can do last. So you should have the templates, everything. When you start in the execution, you should prepare the report while you do the execution, and then you can consolidate it later. Okay. Then, otherwise, if you are waiting till you execute the report, compile the report last, you are going to waste that time. And you can do that while you do the execution. You extract whatever you need from the monitoring tools. Otherwise, those are going to be history, and you have to backtrack, and again, you have to take it. So those are a few tips. Those are my 10 tips for the performance testing. Okay. So we are going to usability testing. Now, what is this usability testing? As you know, it's user experience, right? But you might think, okay, how you should compare usability with performance, the other security and all. Now, as you can see in this diagram, usability testing is all about some customer interacting with an interface. Okay, that interface is not always a UI like nice web application. It can be even a terminal. Okay, it can be a mobile, any interface. Everywhere, even without a GUI, usability is exist. So compatibility is all about different compatibility. It can be web browser compatibility, it can be resolution or the mobile, even the terminal, right? And then the platforms. So there are compatibility is about how compatible the solution to different platforms and versions and all. But usability is all about user experience. So these are two different things. But compatibility and performance testing are part of usability testing. That's how you should think about it, because compatibility and performance is improving the usability. So it's nothing like something else. Okay. Right. So first tip of usability is performance, compatibility, and security. All contributes to a better user experience. So if you are worrying about usability, you need to think about the other aspects also. And then ensuring the quality of usability is the most difficult thing, because it's very subjective, right? It's very, even let's say even requirement specification, there are mockups, right? In UI mockups, those are maybe not not written. Everything will not written in your document. The functional will be written, but UI will be a mockup. So it's very subjective when it comes to testing. It's very challenging, right? So testing the usability is a difficult thing. So you need to plan it properly. And when it comes to requirements, like I mentioned, it's the most ambiguous, right? And then other thing, you have to wear the hat of end user and go beyond requirements. So you have to think about the common sense of when it comes to usability testing. It's not always about requirements. Maybe your requirements are wrong when it comes to user experience. So that's why you don't just raise defects when it comes to usability testing. You have to be more enhancements. You have to raise more and more enhancements. So that's how you add value to the usability testing. Right. Number 6, draw your boundary when ensuring usability. What is the boundary? Because how far you can stretch your arms when it comes to usability is very broad, because let's say there is a public facing application, public facing web application or mobile application. How far you can extend your test? Because it will be publicly accessible. Everyone have different mobile phones, different web browsers. How you should make sure you test everything? So you have to make sure you draw your boundary when it comes to usability. In this scope, this is the result. This is how the quality is ensured. And then compatibility testing is not a must for ensuring usability, but it add value and expand the range. Right. So it add value and expand the range. And then use real hardware in critical points. Now, this is very important. When it comes to usability, you have to think about using simulators and emulators. Simulators are software environments. Emulators are like hardware plus software environments. So you have to identify correct emulators when you do the usability testing. And even in critical points, you definitely have to think about correct hardwares also. But don't wait till all the hardware is in your reach to do usability. That is not practical. You have to think about, you have to use simulators, emulators as far as you can to do usability as well. Identify all types of required compatibility. Now, like we mentioned, compatibility adds value to usability. You have to identify all the required compatibilities also, because that's part of the test. The other very important aspect is you have to think about who really going to use this, where they are, right? What is their culture? What is their geographical changes? Because the way you think about the user experience here is different to a different location, different people. So you have to make sure that is in sync. Okay. Right. So with that, I am going to security testing. Okay. Now in this image, you can see security. When it comes to information security, there are key pillars, 3 key pillars, right? We call it CIA triad: confidentiality, integrity, and availability. Along with that, we can think about 2 more: authentication and authorization. Right. Now, how security impacts to non-functional aspects. Okay. Like I mentioned here, authentication, authorization are all functional, right? So authentication is a functionality. You have to log into the system. Authorization is a functionality. It's a user privilege. Okay. You have different user roles. Those are functional aspects. So people say security is a non-functional testing. That is wrong. No, security is not purely non-functional testing. It's all around. When it comes to integrity and confidentiality, can we say that is non-functional or functional? We can't say that, because that's about the impact. Integrity is all about unauthorized alterations to your day-to-day operation. And confidentiality is unauthorized access. So how you say it's functional and non-functional? That is impact, that is overall. But when it comes to availability, that's where the non-functional is. That's how I think. So you need to think about the availability of the software when it comes to non-functional aspect of security. The other areas you can plan with your functional testing. So there should be set of test cases for functional security testing. Okay, it can be authentication, authorization, and it goes beyond that. It's a different topic, right? So today I'm talking about availability now. It's part of security. Now, availability and performance, 2 different things. Performance is all about the load, the data volume, the parallel users, everything. But when it comes to availability, it's all about being available, being accessible to the customers. So these are 2 different aspects. You need to understand that is very clear. Okay. And now I'm going to discuss a bit more about set of software availability controls. So starts with redundancy. What is redundancy? It's duplicate components. Always a backup is exist. For an example, a database. So when it comes to redundancy, there is a backup database. So we call it like master and slave, maybe, right? Some backup database exists which is not active, but it's in sync with the master DB. It's always in sync, but it's not inactive. It's a backup. So that's about redundancy. So redundancy comes with deployments. It's not comes natively with the code. So availability always with the deployment. That is something you need to understand. And failover, switching to redundant component. That is what failover is. Redundancy should be there to exist failover. So failover is all about switching to that redundant component. Okay. Resiliency, ability to withstand a failed situation and securely fail. What is it? So our software should be able to withstand within a failure. Okay. Some particular module, maybe there is a failure, but other operations should withstand. Okay. And what is fail securely? We should securely fail it. We should control it. Otherwise, our whole system will go down. And what is fault tolerance? Degrade to a minimum functionality. It's like maybe with the failure, it's degrading it like a safe mode. Okay, so that's what fault tolerance is. High availability, minimum downtime. It's minimum downtime. That's what high availability is. And recoverability, fine. Ability to recover the lost data and resume the functionality. Recoverability testing is very important. Something we not always think about when it comes to first production. We always try to, do the implementation and meet the functionality. Then only we are thinking about these areas. That's non-functional aspects, right? So recoverability should be right, from the design. We should have keep provision from the design to keep the recoverability. Otherwise, if you are trying to meet the recoverability later after the production, it's not going to happen. If that is not existing in the design, not existing in the architecture, that's not going to happen. So 10 tips of availability testing. Understand the high-level solution architecture. It's a must. Without architecture knowledge, you can't do availability testing because there is a greater collaboration with your DevOps is required. And understand the production deployment architecture. It's whether it's an on-prem or a cloud, what kind of production deployment is there. So it's a waste that you do availability testing in a different deployment in your test environment, and your production deployment is completely different thing. It's a waste of time. We don't have time to do that in our typical agile development. So you need to make sure your production deployment architecture, and you should do the availability testing in a similar environment. You don't have time to do twice. Right? And if the test environment is not identical to production, keep this test to last. That's the last option we have. We don't have other option. Maybe we can tell client that, okay, can we take the production environment to a week or something like to do this test? Otherwise, we don't have a test environment. Maybe you have to do it at last. Okay. If you do have a similar environment, definitely that's a luxury. You can do it if you have time. Right. And then the other fourth point, if the deployment is in an on-prem deployment, if your production solution operating in an on-premises one, it's not a cloud, then you can ignore high availability, redundancy, and failure, because that comes with a cloud most of the time, like 99%, I would say even 100%, high availability comes with a cloud deployment, because that kind of a complex, sophisticated deployment environment only can offer high availability. So if your system having a high availability cloud deployment, maybe there's a chance of high availability, but that doesn't say if your deployment is a cloud deployment, always it will be a not high availability, because that is based on the client need, and it's very costly. The maintenance is very costly. Because of that, all the cloud deployments are not high available. So DevOps are the best experts on this. So we should collaborate with them and understand what kind of deployments our solutions are. And based on that, you can plan. So high availability, redundancy, and failure comes together. And if your solution is on-prem in production, most probably you don't have high availability in those things. And the database, get the access to database, server, and logs, because you need the access to the database, server, and logs to do certain validations with the dev and DevOps. It's not a standalone QA team only test anymore. And in number 6, failover does not exist if redundant components are not there. Because in order to have failover, you should have redundant components. Right? If you don't have redundant components, failover is not there. So by just looking at the architecture diagram, you can't locate this. You have to ask about deployment diagram from the devs. Okay, if you don't have devs, whoever do the deployment, you have to ask about the deployment diagram. That's where the redundant components are mentioned. But developers, when they're doing the architecture design, they are not mentioning redundant components and no, that is part of the deployment architecture. Okay, right. Then testing the high availability is complex. It needs separate planning along with disaster recovery. So who tested disaster recovery? It's very few in the industry who tested disaster recovery in their systems, right? It's really need a sophisticated planning. Otherwise, you can't do high availability test. Another tip that you need to take. Focus on recoverability, resiliency, and fault tolerance first. That is my tip. Because recoverability, resilience, and fault tolerance, things that we can test without that much complexity. Okay. So that is a very good tip that you can take from the availability test. How you can plan recoverability, because developers can plan the recoverability from their code base. Then number 9, with proper preparation and understanding the environment, you already executed most of your scenarios. That's the other key tip. You don't need to test everything last. With the proper planning, designing, talking to team, you already half executed your plan, because you already know what are the things you need to consider and what are the things you don't need to consider when it comes to availability testing. Right? And the other important tip is better you have some Linux terminal, software development environment related ability, like Linux terminal command, some basic ability, so that you can navigate through a server and access a log file, understand the commands. That is a luxury. That is something good to have when it comes to availability testing. So those are the 10 tips of that. Right. Now here, this is a very brief nutshell about some tools that we usually use for performance testing, but this will different from project to project, company to company. It's different, but most of the industry using these tools for performance testing. JMeet is a very good tool, open source tool for scripting. Grafana, New Relic can use for monitoring dashboards, monitor the server specs, push your client-side specs to Grafana and share your nice reports. They are visualization tools. New Relic is a more of a monitoring tool. There's a monitoring agent and all things, but Grafana is more about visualization. You have to put the data source and then only to visualize nicely. Progress Telerik, it's a kind of a API inspection tool. It's very important. And Postman, and like if it is cloud, there's a cloud consoles, like in AWS management console, you can use for all the monitoring work. If your project is in AWS or GCP, there are dashboards available. Ask from DevOps and get the access. So that's the best tool. You don't need any other tools when it comes to cloud. You already have that. Make sure you have access. And ELK, Elasticsearch, Logstash, and Kibana, it's a collection of logging and monitoring. It's another tool. So those things you can use for performance testing. I have not mentioned pricey tools like load run and all. Those are there anyway. And usability, right? Usability now, it comes with the browser also, like Google Lighthouse gives some good usability testing analysis. And tools like Android Studio, Genymotion, the simulators, you can use for mobile usability testing, and you can use them for compatibility testing. And UserZoom, it's a paid solution. You can do a very good sophisticated usability testing if you are into that level. If you are into that advanced usability testing, UserZoom is something good that you can consider. And Browser Stack, a very popular compatibility testing tool as well. And tools for availability testing. OWASP, a security testing tool. You can use that tool to build your site tree and understand the APIs. You can proxy the site and you can easily access all the site tree, and you can do much of a test with that. And then DB managed DBMS, it's like MySQL Workbench and MongoDB. If you are having a MongoDB related DBMS, those things you can use. And you can use Terminal. Definitely, Terminal is a very good tool. And Fiddler is a very good tool. You can inspect the APIs and you can repeat it. You can do many things with that. And another tool is very popular tool with the DevOps community is MobiXterm to access SSH your servers. Not only SSH, you can use different mechanisms to access server, like even RDP, remote desktop with Microsoft. Any different access is available with this tool. It's free. You can use it, and you can use it as a single source of tool for all your server access. Okay? And it's have a history, and it's very easy. Other than rather you get a native terminal and access every time with an IP and a port. So those are tools that you can use for availability testing. Right. Okay. Now, finally, QAs are now evolving. That is something I would like to remind. Modern software development teams are integrating testing earlier. Something you might already heard in the software development lifecycle. We call it now like not quality assurance, like quality engineering, right? Because we are not testing last now. We are testing early. We are not bug finders. We are bug preventers. That is something you need to keep in mind when it comes to quality engineering now. You always should try to prevent the bugs, not like detecting the bugs last. So with all this non-functional testing, also you need to think about early testing. How far you can do early testing. It's not maybe 100%, but there is a possibility that you can do certain early testing, non-functional testing. So with that, bring your quality to the next level, to the 2.0. And with that, I'm going to wind up for today and open for questions. Over to you, Beanie.
Thank you for sharing such valuable insights on Quality 2.0, Chandima. So we will now have the Q&A session where you are most welcome to type in your questions in the chat, and Chandima will answer them. Over to you, Chandima, once again.
Sure. Thank you, Dini. So the first question, when it comes to non-functional testing, shouldn't we consider accessibility as same as these three key areas? Correct, right. Accessibility we should consider. That's something we should consider definitely. But accessibility is something that is very specific, because most of the solutions, accessibility is not the primary factor, but some of the solutions, that is a primary factor. User experience and accessibility is a key thing. That's correct. But here I took performance, security, usability, key areas, and accessibility is within the usability. That's correct. But accessibility, you can plan it differently. Actually, that's a different topic, but I agree with this comment. Yeah, good. Thanks for taking up. And the next thing, since there are many aspects of non-functional testing like performance, security, usability, can we prioritize them in conducting test executions, or should we consider them parallelly? Let me reiterate. So, can we prioritize them in conducting executions? Right, yes. Certain things you have to wait till the end, right? Because let's say performance testing is doing upfront without everything is not in place, it's not good. You have to wait till the application till it gets stable, okay? But still, you can plan performance testing in isolation before comes to even to the front end, right? Let's say there is an integration in the back end. You can collaborate with the developer and ask him to add the enough logs to measure the round trips and do your performance test. You don't need to wait till the user interface to do the performance test, right? So there are opportunities like that. You can do performance testing early, but that's based on the scenario, right? Let's come to security. You don't need to maybe stay till last. Maybe if there is a user inputs are available, you can try them out. But this might not say like you can complete the test, right? But you can start early. That's the key takeaway. And you can do parallel if you have enough resources. That's the other part. Definitely you can do parallel, like performance testing and security in parallel, but if that is in the same environment, it's quite a bit of a challenge. But if you have enough resources, definitely you can plan it parallelly. Yeah. So let me go to the next question. What are the essential skills to be a good performance tester? Okay, that's a very good question. So to become a performance tester, you should have a good understanding about some DevOps practices, some understanding about the architecture of the solution. Okay. So you should have understanding about the deployments, how it works and all. So that is whole basis about it. And the other part is you should have good ability to scripting. Not only scripting with JMeter, even a bash script would do in certain status. Okay, so shell scripting, Linux access, because most of the servers are with Linux now. Certain things are with Microsoft. So whatever the server, you should have ability to go through them. I understand where your deployments are. That ability is a plus to a performance tester. If you are doing execution, monitoring, everything alone. But if you do have a separate team for the monitoring, maybe you don't need them, or you only need to do scripting and execution. So that's depend on your scenario, right? You should have, to summarize, you should have a good ability to have some scripting language, some scripting tool, and with that is half of performance testing, and monitoring ability and the planning and everything is there. So that is how should be. And one last thing, not always API performance testing, UI performance testing is always there. So those things are there. As a beginner, is there any reference to learn performance testing? Oh, yes, it's just a matter of knowing what tools to look at. Okay, there are very much resources available in the internet. There are many sites available like Tools QA. I can't remember the names, but YouTube is another very good source. You can, like, if you would like to learn JMeter, there is a many resources available, but that experience will not be there. So the other important thing is you need to do performance test practically to get the experience. Otherwise, how much you train with the tools will not you will not get that experience end to end, from planning to execution to sharing results. Because when it comes to execution performance, it comes with the maturity. So my suggestion is, don't try to be a performance tester when you are entering into the career. So you should understand the typical working of a solution, how the industry grade solution will work, how the business will work, get some foundation, understand the surroundings, and get some maturity, and then comes to the performance aspect. Otherwise, understanding this performance in a very junior level is very much challenging. So the best approach would be that. Right. Is there any free tools to do? Yes, JMeet is a free tool to do the scripting, but you know JMeet and you can do scripting, that will not complete your performance test. When it comes to free tools, for anything, free tools are available. When it comes to scripting, monitoring, for any task, free tools are available. Like, let's say, JMeet is the best go-to free tool for performance testing, but there are some other tools also. When it comes to monitoring, Neuralink having a community, there is some threshold. That is a very good monitoring tool. And ELK is an open source tool. Those are there. Right. What are the best non-functional testing aspect of game testing? All right. What are the best non-functional testing aspects of game testing? Right. When it comes to game testing, to be honest, I don't have any experience on game testing. But as we can think about the game, it's very high resource consumption. So definitely you need to think about the server side aspect. And then the client side rendering is another thing that you need to think. So GUIs, the graphic cards, monitoring the graphic cards resources is the other aspect. So there are some unique areas when it comes to game testing of non-functional aspects, something that we can more research as well. Right. What will be the challenges to be a performance engineer? Yes, the challenge is understanding the gravity of a solution is challenging, because you always don't have the visibility how the clients are, how the productions are, because certain production environments operate by the clients. So always understanding the real business situation is a challenge. So based on that only, the efficiency or the productivity of your performance test will have. So that is the real challenge. And other challenge is like learning these tools and all is a challenge, but with correct planning, you can do that. It's not rocket science. Okay. But the other challenge is planning your executions. Most of the members, they can do JMeter scripting, but they can't plan the execution, because they don't know they need to do some trial runs. They need to do some 1 minute, 2 minute trial runs, tweak your test, right? Then expand your test, make sure that is consistent, and read the API responses. What is 500? What is 400? How you should plan based on your response, to whom you should reach out to. If it is 500, it's a DevOps. If it is 400 or some, it's a developer. Right, so those are the challenges. Tweaking your execution and come up with a conclusion is the challenge. That comes with maturity. That's why, like I mentioned earlier, for that you need some maturity and some experience to become a good performance engineer. Is there any high value for the performance testing in the job market? Yes, definitely. It's high value, because performance testing is always needed for any software. Before the first production deployment, we should performance test it, right? But when it comes to the frequency, performance testing frequency is less. Okay, so because of that, very good demand, but when it comes to opportunity, it's compared to normal day-to-day testing, it's less. So that you need to understand. That is why the demand is high also. So that is how the opportunities are there in the market. But definitely, there's a very high value. All right. What are the free tools for mobile app security testing? Yeah. When it comes to mobile app security testing, you need to think about Android and iOS separately. And when it comes to Android, you can use free tools, even like Android Studio is a good tool. but you have tools like MobSF and tools like Droser and even Exter. So those are there, like MobSF, Quark, Androbugs. So there are many tools there. You just need to put the APK and then it will give the results. There are many different ways of doing testing. When it comes to iOS, I don't have any project experience on iOS security testing, but there are a set of tools available in iOS as well. But when it comes to Android, it's more broader when it comes to tool availability. That's a very brief answer about that. Yeah. Any other question?
All right. So due to limited time, we'll be like stopping taking questions.
Sure.
But you can reach out to Chandima on LinkedIn and drop any questions. I think he'll be happy to answer. And also, if there is any further questions, he can answer through the chat itself. Thank you so much, Chandima, once again.
Thank you very much, and thank you all.
All right. Thank you. All right. Next up, we have another amazing individual. She's a skilled performance engineer who is enthusiastic about performance evaluations and pinpoint potential improvement areas. She has years of industrial experience and currently she is a senior lead performance engineer at 99X. She is also an IST QB certified performance tester and an MSc degree holder in computer science at the University of Mooratoon. She is none other than Sugandhika Amaradasa, here to speak on performance testing through real user scenarios. Over to you, Sugandhika.
Thank you, Dini. Let me share my screen. Hope you could see my screen.
Yes, we can.
Yes. Welcome back to the second session of the day. So today I'm going to talk about performance testing through the real user scenarios, which is most related to the session done by Chandima. So first of all, I would like to take you through the highlight of the session. So here I would like to discuss some interesting area on performance testing with the question that popped up in the chat. I thought you guys mostly interested in performance testing as well. So here I am going to talk about not about the typical performance test, but the performance test that we could use easily. So then how we could do that. So that's what I'm going to talk about. So to elaborate that, I would take you through the performance testing levels, client-side performance testing, level performance testing, and also concept called early performance testing. So let me start with the brief introduction of performance testing. As I saw, you guys are most interested on what is performance testing. So when it comes to the performance testing mostly involved with the multi-users, right? We are doing a test as a user. So it is we call it single user test. When we do functional test, it's a single user test. So performance test mostly involved with the multi-user. So we are using different tool to actually virtualize the multi-users. So we use JMeter kind of tool. There are some commercial tool like load runner, performance center kind of tools there. So we can create multi-user using those tools, and we can perform a load into our application and test how our application is built. Simply, that is a performance test. But there are certain when it comes, there are different kind of performance tests. So today I'm not going to talk about typical performance tests like load test, stress test, endurance test, scalability test, volume test. But they are the one we used to measure the performance of the application, because it's involved multi-users. We create the script with the user flow, or maybe we can use a API request, and we create the script, or we record the script, and we change the dynamic value and make it work as a virtual user. So once we make the script to work as a virtual user, you could add any number of user and test with that script. Okay, so that's once we create the script, we can execute. When we execute, as Chandima said, we can do monitoring with the dashboard and with the logs and with some with the capacity of the tool itself, the performance testing tool itself. Okay, so but today, maybe fortunately or unfortunately, I'm going to not going to talk about that, because most of the resources are available available there. You can refer on that aspect. So I'm going to talk about what we can do to identify the issues that we are not covering through the performance test that we typically perform. Right. So when we are performing a performance test, we should have a stable build. Right. We are not going to perform a test on a build, the unstable build, because if we it's a obviously if it's not stable, you can't handle one user at least. But if you are putting a lot of users, then there is obvious issues there, obvious functional issues there. So when it comes to the performance test, you should have a functionally perfect, stable build and the environment. Okay, but in here, but sometimes we cannot. Sometimes when we do that test, before we do that test, we can identify some issues before the performing that, or while doing that test also we can perform these tests. And these are easy tests, so when you can try it out today at home, so and see how it's how beneficial it is. So let's see what are the things that we could not identify with the typical performance test. We could identify, but we are not focusing on these areas because we are mainly focusing on the client server interactions in the typical performance test. But in here, we are normally we are focusing on things other than the client server interaction. So if I give you an example, for the client server interaction, so when you are logging to an application, you click on the login, you will make a request to the server, right? That is called client server interaction. In a performance testing tool, we capture that request and also the response, and we change the dynamic value inside it, and we make it as a script and use it for to simulate the virtual user. So that's what we do in a typical performance test, and those are the previous diagram shows what kind of testing there, right? So other than apart from that, there are some areas we should consider, but these are some kind of neglectable because to compare to the overall performance. But if you could we could improve a lot if you are considering these areas as well to have, right? You will I will take you through one by one. First one is the client side issues. So we do client side performance testing for that, and also code level issues. So it means that we are checking the functional level performance of the application, and see we improve there, in the code level, without thinking other than other aspect, right? Also we can see check the database level issues, also some API related issues as well. And apart from all four, there are some modular level testing we can perform. Then if we do so, we can identify the issues hide out in simple modules, because of the if overall performance is good, no one care about this. But when we expand our user base, then there is a lot of these issues might cause a serious performance issues. So, but if we when we do identify this thing at the beginning, and we fix it then and there, as Chandima said, we fix early, we can have a proper product at the end, right? Okay, so I will explain each of the how we do these tests in each of these tests. So before that, I would like to explain what is the real user scenarios, because my topic says so. So then when it comes to the real user scenario, what I refer is it is actually a behavior of the actual user, right? If you're in other words, it's describe the realistic situation relevant to the design of the solution. If I give you an example, if you are using an e-commerce site, as a user, you will log into that site, you will add thing to in your cart, and you do checkout and you will log out. That is your real time scenario. So when we test through this real user scenario, as a user, we don't see what areas in the infrastructure or architecture we access, right? But as a technical person, if we see through the real user scenario, there are a lot of architecture, resources, and infrastructure involved with this user scenario. So if we are testing through these real user scenarios, and if we are testing each and every area that we would hit with this real user in user task, so it called real test performance testing through the real user scenario. So I hope you got the top. So then next in next slide, I would say I would elaborate more bit on what are the level that could affect with the real user scenario. So if we are the user, you will access to the client. So when it comes to the client, you will have a browser in that client side. So even in the browser level, for each and every application, there are some tasks happening. Once we load, some resources will be cache. So then those things are there, and that also one aspect. Then with the code base and the web application server and web server and things, and the network and the database, these are the infrastructure or backend that we hit when you go through the real user scenario. So if I take the client side mean as a user, where you start to access the scenario. So let's say you have an e-commerce site. In the e-commerce site, you are loading a page. So via the browser. So when we load your browser, there are mainly two type of tasks is happening. One is client side task, other one is client server task. So it's mean some tasks are happening in the client side in your browser, other task is happening in the through the client and server. So in that case, so clients we are measuring the client side performance. So when it come to the client side performance, what kind of things you prefer as a client side performance? So let's say if you are familiar with front end, so you know that when we are loading a page, there is a rendering time. So there will be a DOM loading time. So there are some JS needed to load some functions in the front end. So, and also CSS and image loading. So those kind of things happening in the client side. So these functions are these functions not involving with client server interaction. So because of that, it won't cover with the client server test, like actual performance test. But we can improve the performance here, because if you have a high like rich web page, then if it's loading slowly and it's there will be a bottleneck to perform your task, right? Because of that, client side performance is really important too, and we should actually consider that as a big um, most user friendly part of the application. So then because of that, we have to take this seriously, client side performance seriously, and work on that. So let's as example, if you are taking a JS execution, let's say you are having a JS as a, if you are working, you know how JS work in the browser, and if you're learning also, you know how to write how to write a JS, right? But if your application has a JS, and if it's taking a lot of time, if you know that it's taking a lot of time by measuring like this, you can actually optimize it further. Even most of the time, the front end issues are related to the rendering time. So rendering time could optimize further by doing lot of fixes, optimization strategies. So but to do that, we have to identify those things. So for that, there are a lot of tools available in the market. So Lighthouse, most of them are free, and even you know Chrome developer tool. So maybe most of the uh, QA and development people using the Chrome developer tool to see the API time, right? Page load time. But next time when you locate the Chrome developer tool, just check whether they have JS execution time, whether they have a rendering time. There's a performance tab, and you can profile it. You can actually when you do a task, you can record it, and you can see the how performance of that page is, right? See how it's working, and you can identify client side performance easily without putting any effort, and you can learn it easy, right? And mostly used tool is Lighthouse, so it's highlights some hotspot also, so you can try them out. And when it comes to the code level performance, you have a experience, if you working with the code, so it's mostly this is for you. So let's say that you have a code and you need to measure the performance of each and every function, because when this is mostly useful when you are doing a development and initial stages. I mean, you can use it at the latter part also, but when it comes to if you are using this initially, you can optimize from the beginning, and you can have a good performing code at the end. That's why I suggested to have it initially, but you can use any time, even after developing the application, you can use this tool. So here what we do is we can trace, we can profile your code, and you can give the necessary permission to the tool, and you can start the UI, and in UI you can perform the your task. And when you performing the task, these tools trace your function related to that task, and it will highlight the hotspot areas that take a lot of time, where that if areas that take a lot of CPU, how long blocking garbage collecting does, how long it will UI freeze. Likewise, it will give you an insight of how performance of your uh, function level, code level, that will be really useful for you to optimize further. So because let's say that you have written in your code in some function in method number one, but with you identify it is taking a lot of CPU, so you can try it out the other method. So you can try it out this some other method, and optimize for it further. So sorry about that. So for this one, we have a lot of few tools, but this is something specific to technology stack. So .trace is for .NET application, JProfile is for Java application, Node.js profile is for Node.js based application. But these are not free tool; these are commercial tools. So you have to pay for it, and but it is really worth for you to improve your code level profile. And I will show you the next in next slide. I will show you some insight of the trace profiling. So let's say that if you do a profiling here, so you, as I said, we start profiling. So once you start the profiling, you can check how for each function how you allocate the memory, how you allocate the native memory, how you allocate the garbage collector. So if you select these filters, it will filter out, and if there is a issue, it will highlight in a red. So if it's highlight in the red, you can actually click on that method and higher results, and you can see the functions, and you can see why it is happening. Also, you can change here, and you can run it again, and likewise you can improve your code then and there. So this is for trace. uh, this is from trace. So say there's another example of from JProfile. Even in here, this is a hotspot, a tool itself highlighting the issues, right? So you can see dig down further, and you can see where it's take the time, which function. Even if it is a function, they will have multiple methods. So in even which method took lot of time. So likewise, you can do code level code. You can analyze your code, and you get code performance. But there's a one difference. There are some tools called uh, level code quality tool, right? Code quality tool mean you will identify the issues in code like null pointer kind of thing. But here we are here for purpose of identify the performance of the code, not for to identify the quality of the code. But sometime if there's a null pointer, there's a performance hit that we could identify. But when it come to the purpose of it, it's not for the measure the code quality, right? So then in the next slide, I would say API performance testing. So API performance testing is something we do with the API. So we only use APIs, and with API we see whether how it's behaved, right? This is we are use this technique we are using for automation as well. But here the purpose of doing performance testing with API is, let's say you are doing a UI performance test. So one API taking a lot of time. So if it's taking a lot of time, then you will uh, you have to do something about it, right? Because you have to fix it, right? You have to optimize it. Whenever you do some changes to that API, if you are running a whole test, is something unnecessary. So in that case, you can do a API level performance test. And some other case is there's some other case that some UI we couldn't record. There's a technical barriers. So in that case also we can use the API automation, sorry, API performance test. So for that also we have a lot of tools out there. These tools are free tools, so we can use them. So we have Postman, JMeter, RedSessio tool, and the SOAP UI tool. And these are the tools that I put just a icon. Right. These are the tests that I would like to cover in this session. And there's one other things that I think Chandima also cover a bit of it. Uh, the early performance testing. So early performance testing mean as I mentioned in the first slide, we have to have a good, perfect product, right? We have to have a functional error less product to do a performance test. So because of that, we are doing that test at the latter part of the development cycle. But we can perform a early performance test in the beginning of the development life cycle. So for that, let's say we have a module 1, as I show in the diagram. In the module 1, we see we can perform some test there, performance test there, and if we have found any errors, we can fix it, and we can test in the next phase. So if we have module 1 and 2, then we have performance optimize module 1 and the other module 2. So we can actually there also we can perform the early performance test phase 2. Likewise, we can perform early performance tests in phases, in each phases, and identify issue fast. Fast mean early, and improve our application further, performance further. And when it comes to the actual performance test, you won't need much effort, and you won't find lot of issues also, because most of the issues you may have fixed with the early performance test. But uh, so I will discuss bit of benefit of doing this test. First one is the performance testing process getting faster, and also when in the actual performance test, it's less number of errors. Errors mean performance bottleneck will detect, right? And also cost reduction. This will, if we elaborate in that further, so when it comes to the cost reduction, when most of the time, most of the project teams doing their performance test at the end, but it's supposed to be like that, but when it is really close to the release, right? When we found a performance issue at the really close to the release things, we might tend to neglect it, and we might tend to compromise that issue. So if we are compromising those issues, we can have the same issue at the actual production environment. Like, if you give you an example, when we have a COVID-19, we had in the Keels website, so it got crashed, right? So they didn't do performance tests. So that's the drawback of it. But they compromise. When we should not compromise the performance issue, so we have to fix it. But if we are really close to the release, we tend to compromise it, and we will see next release. That's how team says. But if we're doing early performance test, we detect less number of performance bottleneck at the actual one, so it will be cost reduction. If we found a performance issue in the production environment, it's really costly. You will lose if we consider the case example, they have lost lot of customers, right? So we can avoid that will be really costly. We can avoid that by doing this. Also, we can ensure the better performance at the early stage itself. And also then if you are doing if you are a performance tester, if you are involving from the beginning of the application development, tester also aware of the issues, the performance issues, and how the application is also, and the developer also know how what kind of issue that we could arise with as in terms of performance testing. Then as a result, the burdens of project delivery will be less. So these are the things we could get as a benefit, but there are some do and don't in early performance testing as well. So where we when we do as I said in the previous slide, so when we do the test in a small module, it also should be some complete feature. But as if we by sake of doing, you should not do the test on small code and a small module as well. But it's you have to think of scope of the module feature. And if you have a complete feature only, you should do that. But because if you are doing it regularly and if you are complaining as a performance tester regularly, then it will be conflict, right? So that should not do. And also, we should not put lot of time on early performance testing, because we should put lot of time on actual performance test as a performance tester. But in early performance testing, we should not put lot of effort. We have to do a test, a performance test with less time. So that's why I explain all these tools, code level profiling tools and client side profiling tools and the API level tools. So those things will be really useful to do a performance test with minimum time, right? So then we don't put a lot of time in each and every time you do the early performance test, but better to do. And also, try to, when you found the if defect in the early performance testing cycle, you try to ask for the quick resolution, because if you fix it before, you will not get that in the actual test. And also, and also before integrate with the third party tool, always perform a test before integrating in, because third party, in fact, most of the time third party tool take a lot of time when we integrate it with ours. So then we should do performance test there before integrate and after integrate, and see how it's impact to our overall performance. So in early performance test, do not use script. So what you should use? You can use the client side performance testing tool, cloud level performance testing tool, and API testing tool. Those things don't need any script. So you can just go and do it easy and less time consuming. And also, don't do, even though it's easy, you should not perform it aggressively. You have to be calm, and you should select the scope, and you should select the right time to perform it, and you can perform those things. Right. That's what I want to share with you today. Hope I am on time. Or maybe before it. Yeah, thank you for listening. If you have any questions.
Thank you, Sugandhika, for that insightful session. And now we will begin our Q&A session. So please type in your questions in the chat and she'll answer them.
I have already 4 questions. Is there anything to check the slowness of the application using browser console? And how to do it? Is there anything to check the slowness of the application? Yes. So these tools, there are various ways of checking the slowness. So this first, if I start with from the smallest tool. So here, if Chrome developer tool. So if you have a Chrome developer tool, you can load your application and you can do your performance test, right? You can actually run through the test, run through the application and see you can do the profiling in your Chrome browser, right? That is the simplest way of doing this. And then that is where browser console thing. You want me to? I hope you want me to show it. So let me do that. Give me a second. I hope you can see my screen now. Yeah, it's a Google screen. So in a Chrome developer tool is this one. Here, even you can see it here in network tab, the performance. So let's say you can start it here and test. Just test. And I will click on this. So these are the here you can see this time. So this is this is where you can see the time of you taken for the each URLs, and also you can use this step. So you here you can use the profile record button. So and do some task and stop it. And you will see a report. I will answer the next question till I get the report. So could you please name the some tool for DB testing? That's differ that because for different database system there are different database tool performance monitoring tool. Most of the databases has inbuilt performance tool. So if you take a SQL server, you can see it's SQL server monitoring tool right there, right? The SQL server performance monitoring tool. So you can use that. That is the best tool for that. And if you yeah. Yeah, because that's why I didn't actually go through the tools for DB testing, because most of the databases has inbuilt performance monitoring tools. Right. I hope that I could answer. So for the first question, so you can get the summary like this: loading time, scripting, rendering, painting idle time, and also you can see the call tree. In you can there are some highlight also if there's a stock calls. So this is how we use the Chrome developer tool to monitor the performance of the application and even the slowness. Right? Sorry. Did you mean continuous performance testing by early performance testing? Are they same? Yeah, these concepts are similar. So early performance, yeah, I mean early performance mean we do test early with some with module. That continuous performance test also refer the same, but the concept are different. When it comes to the continuous performance testing, you should consider the it should continuate. You can't continue. You can actually stop it, right? Like let's say when we start the continuous test, we are starting with the code level. Then it come to the code level mean implementation level. Then it come to the other stages. In each stage of the development life cycle, you have to do the test, right? Continuous performance test is like that. And also once you have released the test, release the product, also we have to monitor whether we are in achieving the same baseline, whether we are achieving the same performance even though it is in the live environment. So that is the continuous performance. That's where it's differ, because we have to make in continuous performance testing, we always have to make sure whether it's within the threshold. So and also thanks for the assistance. Thank you for the compliments. And as an experienced performance tester, what is the advice you to the beginner fresh undergraduate to start the performance testing? So yeah, it's a bit tough question. If I share my experience when I start my performance testing things, I actually start with I got some good references, like I start with the load runner tool. They had lot of documentation. So when it comes to documentation, it's really matters when we start as a beginner, right? There are some concept we have to identify as a performance tester. If you identify those concept, for correctly, it will be easy to apply with any tool. Like let's say that you are doing a test with the there are mainly you have to identify that how to handle the dynamic value. There are two type of dynamic values. One is test data, that like username and password. The other one is things sent from the data server. So that is called parameterization and correlation. If you get it right, you just go and search. If you get it right as a beginner, so you can learn other things easily by reading things, right? So yeah, when it comes as a fresh graduate, and if you are trying to start, try don't actually read everything. Try to identify the big picture of the performance test and dig down there. Try to identify the big picture and then read, right? Without reading everything, it will confuse you. But try to identify the big picture of the performance test. There are a lot of resources available. Then start. Then you will know where to start. So then you can do it. You can start learning and performance testing, and also always try to get help from the senior people. I got a lot of help and when we work, right? You will also get when you join the big in the company. Then you will get senior help also. So you can. It's really interesting area. I really hope to see you there. And also, is one thing, are there any resources to learn performance testing practical scenarios? Yeah, there are a lot. So even CQC has done a JMeter series, so you can actually get some. There are some JMeter resource also there, so that because of the CQC organizing this, I am saying you. So and also there are a lot of resources available. Guru.lk.com, so there that also has a lot of resources. And other than that, JMeter and Load Runner platform has a comprehensive and detailed description on performance, and they teach everything from the beginning. So then if you go there and start learning from those documentation, you can learn a lot. But like I said before, I try to understand the big picture of the performance test and start learning without reading from the beginning. That will confuse you. Yeah. So hopefully, thank you for asking question also. Thank you very much. And with that, I think audio Dini. Thank you very much for listening to me.
Thank you so much, Sugandhika. So with that being said, we conclude day 4 of Quality Week 2022. We're thankful to our speakers, Chandima and Sugandhika, for sharing their knowledge and expertise. Thank you to the participants for joining this session. You have been a great audience. Looking forward to seeing you everyone in tomorrow's sessions, where Prasad Senaratne and Hype Scoots will be joining in to speak on testing in DevOps and testing in modern times, a story about quality and value. Before we wind up, please take some time to fill out the survey we have mailed over to your registered email address for us to gain more insights into improving the Quality Week sessions. And with that said, have a wonderful evening, everyone. Looking forward to your participation in our final 2 sessions happening tomorrow. See you guys.